To understand the shell method, we look at a single vertical representative rectangle. This rectangle has a width of dx and a height determined by the function value f of x. We will rotate this single rectangle around the y-axis. As the rectangle rotates, it forms a thin cylindrical shell. The radius of this shell is simply the distance from the rotation axis, which is x. The height of the shell is equal to the height of our rectangle, which is f of x. If we cut this shell and flatten it out, it becomes a rectangular slab. The length of this slab is the circumference of the shell, which is 2 pi times the radius x. The height remains f of x, and the thickness is our differential dx. The volume of this single thin shell, which we call dv, is the product of its dimensions. By multiplying the circumference 2 pi x, the height f of x, and the thickness dx, we get the differential volume element. To find the total volume of the solid, we sum up an infinite number of these shells using integration. The total volume V is the integral from a to b of 2 pi x times f of x with respect to x. Let's apply this to an example. We will find the volume of the solid generated by rotating the region under y equals x squared, from x equals 0 to x equals 2, around the y-axis. First, we identify our components. The radius is x and the height is x squared. Plugging these into our formula, we get the integral of 2 pi times x squared, which simplifies to 2 pi times the integral of x cubed from 0 to 2. Now we integrate. The antiderivative of x cubed is x to the fourth divided by 4. Evaluating this from 0 to 2 gives us 16 over 4, which simplifies to 4. Multiplying our result by the constant 2 pi, we find that the total volume of the solid is 8 pi cubic units. This represents the entire space occupied by the rotated region. In summary, to use the shell method, identify your radius and height, set up the integral using the circumference height thickness logic, and integrate over your horizontal bounds. This method is a powerful tool for complex rotations. Mastering the cylindrical shells method allows you to solve volume problems that might be difficult with other techniques. Thank you for watching this lesson on calculus. Generated by Vision Solve AI.